Good morning, students. So today we are going to start with the new topic, that is the cryptographic building blocks. So today we are going to cover this under the fifth module. So we are going to see some of the things here. That is, before transmitting the information into that particular network, so how you can protect your information from the attackers, in what way you can protect it. uh, you are going to see some of these things in this particular the module. So the concept of the cryptographic based security, step by step we are going to learn under this particular the chapter. So we are going to using the cryptographic algorithms are parameter by the keys and addresses the problem of distributing the keys. Is it clear? So now we are going to study about some of the cryptographic algorithms which are parameter by the keys and addresses the problem of how you are going to distributing the keys. So now the question here it is that what you mean by the key, what you mean by the algorithm, what you mean by the cipher text, what you mean by the plain text, what you mean by encryption, what you mean by decryption. Is it clear? So lot of these particular terminologies are there. So first we are going to see about that, what you mean by the cipher text. Okay, so why we are going for encrypting the information, what you mean by the process of encryption, what you mean by the process of the decryption. So the first one here we are going to see about that cipher text. The cipher text is also known as the encrypted text, or you are also going to be call it as an encoded information. Is it clear? So the information which you have been transferred it into the another one form, that is what you call it as into the encoded information, because it contains the form of the original plain text. So that is unreadable by the human or the computer without the proper cipher to decrypt it. Is it clear? So this is here what you are going to be called it as a cipher text. Cipher text is nothing that it is also known as the encrypted information or encrypted text, or you are going to be called it as encrypted encoded information. Is it clear? So the original plain text is going to be converted into the cipher text, that the people cannot read it. This information you are going to be transmitting to the networks. So there is a chance that you are sending this information into the untrusted network, into the unsecure network. So there is a chance of that a hacker or the attacker may hack that information, and you wanted to read that information. To protect from that, you are converting that plain text into the cipher text. That cipher text is in a unreadable by a human or the computers without the proper cipher to decrypt it. Okay, now you are going to see about what you mean by the encryption. The same thing here, it is that encryption is nothing but it is the process of encoding the information. This is the process which converts the original information or the plain text into the alternate form. It is known as the cipher text. Is it clear? So this is the meaning of both the cipher text as well as the encryption. That is the process of encoding the information, converting that original information, that is a plain text, into the alternate form. Is it clear? So that is known as the cipher text. Now what do you mean by the decryption? It is the inverse of the encryption. So it's the process of turning once again the cipher text into the normal readable the plain text. That is the conversion from the cipher text into the plain text. So how you are going to convert this? This is the process here what you are going to be call it as the decryption. Is it clear? Now here we are going to see about that the principles of the ciphers. So that is here the encryption transforms a message in such a way that it becomes that is unintelligible to any party that does not have the secret of how to reverse the information. Is it clear? So once you have been converted your plain text into the cipher text, is it clear? So you are going to require some secret key. With the help of that you are going to make a reverse transformation, that is you are going for the decryption of that the information, that is conversion of a cipher text into the plain text. Without that particular the secret key you cannot convert the cipher text into the plain text. So now the sender applies an encryption function to the original plain text or the message. So now that is resulting into the cipher text message that is sent over the network. Is it clear? So now I am going to show you to the diagram how exactly it is going to work. So here you are having the message here. Is it clear? So that message is going to be encrypted here with the help of a one particular key called as the encryption key. So after that encryption, you are going to be call it as the cipher text. So this cipher text is going to be transmitted through the network, that is insecure network. Is it clear? So it is not a secure, it is an insecure network. You are transmitting to the internet, you are transmitting into the outside world. Is it clear? So this cipher text is transmitted to this insecure network and reaches to the destination. The destination side, the receiver machine is going to receive the message in a encrypted format, that they are going to receive the cipher text, and this cipher text is going to be decrypted. So as I told already, using some secret key. Okay, you should have some secret key. With the help of that, you are decrypting the message. Okay, you are decrypting the message, that converting from cipher text into the plain text. Is it clear? So this is the process here what you are going to be following whenever you are going for encrypting the message, converting into the cipher text and transmitting to the network, and the receiver side is going for using the secret key for decrypting the message. Is it clear? So this is the process here what you are going to call it as a encryption and the decryption. Now we are going to see the things here, that is the receiver applies the same secret description function, the inverse of the encryption function, that is to recover the original plain text. The cipher text transmitted across the network is unintelligible to any eavesdropper. As I told already, you are protecting your information from the eavesdropper. Is it clear? You have to protect the integrity of the data what you are going to be transmitting. The information should not be modified. Is it clear? So for that, that is, you are protecting your information from the eavesdropper. You have to protect it, your integrity of the information. Okay, assuming that the eavesdropper does not know the description function, even though if you hack that information, if it doesn't know the key, if he doesn't know that secret key, so he cannot convert it into the plain text. He cannot convert it from the cipher text into the plain text. Is it clear? Now the transformation represented by an encryption function and its corresponding decryption function is called a cipher. As I already explained in the diagram, that is the transformation represented by an encryption function. The plain text is given with the help of that encryption algorithm. You are going to be converting it into the cipher text and then transmitting to the insecure network, and on the receiver side, with the help of the key, decryption algorithm is going to be used. Okay, and the decryption algorithm, with the help of the key, you are converting back cipher text into the plain text. Is it clear? So this is a complete that function here we are going to be call it as a, this is a cipher represented by the encryption function, and this corresponding decryption function is called a the cipher. Okay, now here we are going to be see about that. Is it not possible that the encrypted message cannot be decrypted? Okay, some of the people are there, that is which we are going to be call it as a code breaker. What they are going to be do? So this code breaker, or you are also going to be call it as a cryptanalyst. Is it clear? So cryptanalyst can use, try to break out the keys, or they are going to break a cipher. Okay, so they wanted to break the key. With the help of that, they can decrypt the message. Is it clear? Or they are going to convert that encrypted into the decrypted plain format. Is it clear? How much they have been succeeded? Okay, how much they have been succeeded? Okay, it depend upon that. It depend upon the cryptanalyst, okay, had broken the key or broken that particular the cipher text. Okay, now we are going to be see about that the basic requirement for an encryption algorithm. What is the basic requirement for a encryption algorithm? So the encryption algorithm which is used for converting a plain text into the cipher text. Okay, so in such a way that only the intended recipient, okay, to whom you wanted to deliver that particular message, only the intended recipient, the holder of the decryption key, can recover the plain text. The holder of the decryption key can recover the plain text. Okay, so what this means is that encrypted messages cannot be read by the people who do not hold the key. Is it clear? So even though the hackers, if they hack, if they doesn't break that, if they are not having any particular key, so they are not able to read the information because it is into the encrypted format. Is it clear? Now we are going to see about that some of the attackers what they are going to be do. So this is the attackers here, what they are going to do is that there is the one method which they are going to follow for breaking the key, or to get that particular key to decrypt the message. So this is what you are going to call it as a brute force search will be there. Okay, what do you mean by this brute force search? The attacker with no choice, okay, but try all the possible keys exhaustive. Is it clear? What he is going to do? He is going to try with all possible keys. If a key has a n bits, then there are 2 raised to n possible values are there for a key. Is it clear? Now an attacker could be so lucky as to try the correct value immediately, or so unlucky as to try every incorrect value before finally trying to the correct value of the key. Is it clear? So therefore, okay, so they would have tried all 2 raised to n possible values. Is it clear? All 2 raised to n possible values for the key, here they have to search. Is it clear? So once again, there is a the thing will be there whether you have to use the large key or the small key. Okay, and the next one is that how they are going to identify it. There is a repeated appearance of the same character in that particular cipher text. Then if they break it one, so they are going to identify those particular characters, and even they are going to find the word like login, etc. Is it clear? These are also the some of the things are there which the brute force search method is going to use. It is studied in another one subject, that is the information and network security, or the cryptography and network security. The subject will be there where you are going to study in detail about this. Okay, now we are going to be see about that. That is, most of the ciphers are block ciphers. How you are going to be converting a plain text into the cipher text? So this is there are a lot of different algorithms are there. So but in this syllabus here, we just going to be discussing about some of the that is about a block ciphers only. Is it clear? So what do you mean by this the block ciphers? So they are defined to take as an input as a plain text, that is a block of a certain fixed size. So what you are going to do here, you are going to taking a plain text, okay, of a fixed size block. So this fixed size block may be typically, how many number of bits are present in this block? 64 to either it may be the 128 bits. Okay, now you are going to using one of the block cipher encryption algorithm. How you are converting that a complete plain text block into the cipher block. So there are different algorithms are there. With the help of that, they are going to converting. So each block is going to be encrypted independently, known as an electronic code book mode encryption. Is it clear? Now we are going to see here, this is the one of the example here which has been given, that is the cipher block chaining. So in this cipher block chaining, how they are going to be converting this plain text blocks into the cipher text blocks. Say for example here, the plain text blocks, first initially the first plain text block is going to be exclusive or with some initial vector, some initial value which you are going to take, they are going to be called as IV value or the initial vector. Is it clear? So the plain text block, the bits which are presented in the plain text block is exclusively odd with the IV, that is the initial vector. Then the result what you are going to get it here. Is it clear? The result what you are going to get it. Now that one will be encrypted using one of the encryption function. Is it clear? That resultant block is going to be encrypted here using one of the encryption function, and then you are going to be converted into the cipher block. Now here we are having a first cipher block, that is a cipher block 1. Now the next process what you have to do is that the next second one plain text block, okay, is going to be exclusively odd with the first cipher block. Is it clear? Now the second plain text block is exclusively odd with the first cipher block 1, and the result what you are going to be get it using the encryption function, convert it into the cipher block 2. Is it clear? Now the cipher block 2 is going to be exclusive OR with the next one third plain text block. Okay, the result once again you are going to get it after the exclusive OR. So using once again the encryption function, you are going to be getting the cipher block 3. So this process continuously works. Is it clear? So that the result is that each block's cipher text depends in part on the preceding blocks. Is it clear? So this is how exactly it is going to work. So I am going to show you this particular the diagram here. Okay, I have explained that method. You just see here plain text block 0, 1, 2 and 3. So whatever the message you wanted to send, you are going to break down into fixed size blocks. Either it may be the 64 or 128 bits, depending upon that you are going to break down into the blocks. Is it clear? So as you know that these plain text blocks are going to be exclusive. First block is exclusively ORed with the initial vector, and the result will be given as an input to the encryption function, and after that encryption you are going to be get a cipher block. So that first cipher block is going to be exclusive ORed with the next plain text block 1, and the result once again will be given as an input to the encryption function. Now you are having a cipher block 1. This cipher this block 1 will be exclusive ORed with the plain text block 2. The result one will be given as a input to the encryption function. Now you are having a cipher block 2. So on. This process is going to be continuous. So this process of converting these plain blocks into the cipher block. So this process here, what you are going to be call it as a cipher block chaining. Cipher block chaining. Is it clear? Now the next one here you are going to see about some of the algorithms, the methods here. One is the symmetric algorithm, another one is a asymmetric. So this one here we are going to be call it as a symmetric key ciphers. Okay, or another one we are going to be call it as a asymmetric key ciphers. Okay, so the first one here we are going to see about that. Okay, so that is a symmetric key encryption and a decryption. In the symmetric key encryption and decryption, here what happens here? Both the participants in a communication, see here, both the participants in a communication sharing the same key. Is it clear? Both are going to share the same key. Is it clear? In other words, say for example, if a message is encrypted using a particular key, the same key is to be used by the receiver to decrypt the message. Is it clear? So this method here, which we are going to be call it as a symmetric key cipher. So now here you are having that message in the plain text is going to be encrypted using one key called as a encryption key. So with the help of this encryption key, okay, so using encryption algorithm, you are converting the plain text into the cipher text, transmitting into the insecure network. Receiver side message of the cipher text is received. Now you are going to using the same key, the key which is used by the sender to encrypt, the same key is used by the receiver to decrypt this particular cipher text into the plain text. Is it clear? So it means that if you want to go for this symmetric key encryption, both the sender and the receiver should, before communication, they should know the common key. They should know the key which is used for encryption. The same key should be used for the decryption. Both should be known with this particular the key. Since it is also known as the secret key ciphers, since the shared key must be known only to the participants. Is it clear? It should be known only to the participants. Okay, now here it is that the NIST has issued a standards for a series of symmetric key ciphers. So they are going to be called it as a one is the data encryption standard. That is the standards for symmetric key ciphers. Okay, this is what you call it as a DES, data encryption standards. So it was the first one. Okay, and it has stood the test of time in that no cryptanalytic attack better than the brute force. Is it clear? So that is no cryptanalytic attack better than the brute force method search has been discovered. Okay, now DES keys have a 56 independent bits. Although they have 64 bits in total, the last bit of every byte is a parity bit. Is it clear? So that is 2 raised to 56 possible keys to find the right one. So giving that is 2 raised to 55 is equal to 3.6 into 10 raised to 16 keys. Is it clear? So this is of the DES. Now if you are going for the 3 DES, now increasing the key size. Okay, a 3 DES key has 168 independent bits. Is it clear? So what do you mean by this? That is 3 DES is 3 into 56. DES is having an 56 independent bits. That is, with the help of that you are generating 3.6 into 10 raised to 16 keys you can generate. Now here it is 3 times of DES, that is a 3 DES, 3 into 56 independent keys are there. It is used as a 3 DES keys. Let us call them DES key 1, DES key 2 and DES key 3. Okay, now encryption process using 3 DES is performed by, okay, the encryption, here it is that the encryption process using 3 DES, okay, is performed by first DES encrypting the block using the DES key 1, then the DES decrypting the result with the DES key 2, and finally the DES encrypting the result using the DES key 3. This is the process how it is going to be used. See the process, I am going to explain it once again. Encryption process using the 3 DES, I am going to explain it once again. Okay, so carefully listen it. So that is the first DES encrypting the block using the DES key 1. Is it clear? The first encrypting the block, the first plain text block is encrypted using which key? DES key 1. Now then it is decrypted. Okay, it is decrypted. Okay, the resultant of this one is done with the help of DES key 2. Then DES decryption, that is the decrypting the result using the DES key 2. By using the DES key 2 you are decrypting it, and once again you are encrypting the result using the DES key 3. Is it clear? So this is the encryption process using the 3 DES. So DES key 1 is used for the encrypting the block and DES key 2 is used for decrypting that. The result is once again encrypted using the DES key 3. So the decryption process using 3 DES. So decryption involves, okay, decryption involves how you are decryption. This is an encryption process using the 3 DES. Now how the decryption will be done? The decryption involves decrypting using the first, using the DES key 3. What you have to do? The message what you have been received on the receiver side, you first decrypt it using the DES key 3. Then encrypt the resultant of that, you encrypt it using the DES key 2. Okay, and then decrypt it using the DES key 1. Is it clear? So this is the reverse process of that encrypting process using 3 DES. So where first DES encrypting the block using the DES key 1, now that one is going to be decrypted using the DES key 2, and that resultant will be encrypted using the DES key 3. Now on the receiver side, what you are going to do? First you decrypt that block using the DES key 3, and the resultant of that will be encrypted once again with the help of the DES key 2, and then the resultant will be decrypted using the DES key 1. Is it clear? So this is the process how you are going for encrypting and decrypting using the 3 DES. Okay, the next one here we are going for the another one, that is the public key ciphers. So we are going to stop it here. So next one we are going to continue with the another one, that is the public key ciphers, or you are going to be call it as a asymmetric keys.